Somebody is joining. Okay. See, so let us discuss about the Kirchhoff current law. The statement is like this: the algebraic sum of currents entering at a node. At first, it is actually defined at a node. We already discussed about a node, what in a node, loop, all those things. Actually, it is defined at a node. Defined at a node. Defined or stated at a node. The statement is the algebraic sum of the currents entering a node, a particular node, is equal to 0. That is the one statement. And we can write mathematically as summation n equal to 1 to n, I of subscript n is equal to 0. So this is the mathematical representation of KCL, where n is the number of branches connected to a particular node. That means, suppose there is a branch. At this branch, one resistor is connected like this. So let us say this is R1, I1 is flowing like this. Another branch is there which is having R2. Another branch is there which is having R3. And another branch is there which is having R4. All these are connected to whom? A source, a voltage source. Likewise, so many elements are connected. So we are considering this node. At this node, I have to write KCL, Kirchhoff current law. Now what this n indicates here? N is the number of branches connected to the node. In this case, how many branches are connected here? Can anybody guess? How many branches are connected at this node? Please respond. Shravan?
4, sir.
Yeah, very good. 4 branches are connected. So we have to expand this summation to n equal to 4. That means I1. That means this is I1 current, this is I2 current, and this is I3. The directions are very important. And this is I4. I1 plus I2 plus I3 plus I4, which is equal to 0. But you have to consider the sign convention here. What is the sign convention here? See, we can take any convention, but we should stick to one particular sign convention. Suppose in this case, I1 current and I2 current, both the currents are entering at the node, entering into the node. Entering means we can treat those currents are positive currents. So I1 current is positive, I2 current, both currents are positive. And if you observe this I4 current, this is I2 current is leaving. This is I2 current, this is I3 current, this is I4 current. So I3 and I2 currents both are, I2 and I4 currents are leaving. Leaving minus leaving means we can take negative. So we can write I2 current as a minus, I4 current as a minus. That is the meaning of algebraic sum. We can say a sum of, but we should say algebraic sum means we should follow some sign convention. That is the meaning of algebraic sum. So finally, what can I write here? Plus I1 current, because it is entering current, and this I2 current is leaving. As I2 current is leaving, I can write minus I2, and I3 current is entering. This I3, this is I3 current. This is entering means plus I3. Again I4 current is leaving. I can write I4. So all the algebraic sum should be equal to how much? Okay. Now another way also we can define. What is another way? Living currents. In terms of living currents also we can define. Here we should follow the sign convention. Current entering into the node are to be considered as a positive currents. Currents leaving the node are negative currents. So till the end of this, you should follow these sign convention. Okay. Now, based on this concept, can anybody guess or can anybody tell me the algebraic equation for this diagram? Please, anyone? If you see this current I1, this is entering current. I2 also entering current. I3 is leaving. I4 is indicates entering or leaving. Okay. So please, can anybody equation KCL equation for this diagram? Anyone? Sai Teja 109. 109 Sai Teja. One zero two 102. 102 Vaishnavi.
Yes, sir.
Why the student is not responding? Mohan Dipti 125.
Yes, sir.
Vaishnavi, can you tell me the KCL equation for the? Yeah, please tell me. I wrote one equation based on the current direction. Now, see the sign convention. The current entering to this is actually a node, right? This is a node. This I1 current is entering. Tell me, this I1 current is entering or leaving?
Entering, sir.
Yeah. Now, am I audible, Amma? Hello. Hello.
Yes, sir.
Yes, sir.
So there is some network issue. Please wait for 1 minute. I will come. Yeah, please. Can anybody tell me this KVL equation for this diagram? Are you able to see this picture here? The currents I1, I2, I3, I4, and I5 are here.
Yes, sir.
Yeah, can anybody tell me? Mohan Dipti, please tell me, Amma. I1 is entering or leaving?
I1 is entering, sir.
Entering means we have to take positive sign or negative sign.
Positive sign.
So plus
I1.
next. What about the I2?
I2 is also entering, sir. Positive. Plus I2.
Positive plus I2. Very good. Next.
Minus I3.
Very good. Minus
Plus
I3.
I4.
Yeah, as it is entering, so I4. What about
Minus I5.
minus I5? So the sum should be equal to what?
0.
Very good. 0. So that is the KCL statement, algebraic sum of the currents is equal to 0. So by using this mathematical equation, I can write, see, I1 and I2 are plus. I am writing, and I4 also plus. I am writing this I3 and I5 at RH side. That means I1 plus I2 plus I4, which is equal to I3 plus I5, right? So finally, what can I say here? I1, I2, I4. I1, I2, I4. So these are called entering currents. These are called entering currents, which is equal to I3, I5. I3 and I5 both are leaving currents. So leaving, in this way also we can state the KCL. Algebraic sum of entering currents is equal to algebraic sum of leaving currents at a particular node is equal to 0. This is the statement of the KCL. So the sign conventions are very, very important while writing the KCL equation for a particular circuit. Once if you understand this KCL, KVL and Ohm's law, we can solve any circuit easily. Okay. So the basic concepts are very much important. If anybody having any doubts, you can please ask me here. So, but you should follow the sign convention. Current leaving current should be treated as a negative currents. Okay, and entering current should be treated as a positive currents. That is the statement. So that is the what here you have written I1 plus I2 minus I3. See here, I1 is entering current plus I1, I2 is entering current, so plus I2, I3 is leaving current, so minus I3, and I4 is entering current plus I4. Next I5 is which current? Leaving current, so minus, which is equal to, so for a given circuit you are should able to write a particular KVL equation at a node. Okay, so this is about the KCL. Yeah. So this is the equation we wrote here. This is the final equation we wrote. We can say sum of the currents entering at a node is equal to the sum of the currents leaving at a node. In this way also we can define. So please tell me, anybody having any doubts in this KCL equation? Shall I move to KVL here?
Yes, sir.
Yeah. Next. This is the second law, Kirchhoff voltage law. So KCL, Kirchhoff current law, defined at a node. This KVL, shortly it is known as a Kirchhoff voltage law, KVL, is defined or stated, defined in a loop or around a loop. Around a loop. Loop is a closed, any possible closed path in a circuit. We already discussed about the loop. Now, the statement is that the algebraic sum of the voltages around any closed loop, any loop, is equal to 0. Repeating, algebraic sum of voltages around any loop is 0. So to understand this one, I will give one circuit so that you can easily understand. You can easily write the KVL also. And let us take at least this circuit also. Take this circuit. Algebraic sum of all voltages. So this is a voltage source. This is a voltage source, and we know the polarities of the voltage is plus and minus. So this is voltage source V0. Let us say this is voltage source V0. And for this voltage source, resistor R1 is connected here and resistor R2 is connected here. Now finally, how many branch elements are in the circuit? Please tell me, how many branch elements are in the circuit? One voltage source is one branch, R1 is one branch, this is R1 resistor, and this is R2 resistor, another branch. Finally, 3 branch elements are there. So as this loop starts from here and it is connected to R1 and R2, and again it is going to the source. So we can say it is a loop. We can say it is a what? Loop. While writing the all voltages, sum of all voltages, as it is a algebraic sum, we have to write sign convention. We have to write sign convention. So for that, already for battery or source, voltage source, the polarities will be given. Even though the polarities won't be given, then you can write longer line will be treated as a positive polarity, and this shorter line will be treated as a negative polarity. So don't confuse here. There are 4 lines. Don't confuse here. These 4 lines indicates this is a variable battery. You can change the voltage from 0 to 20 volts like that. But let us take. This is a longer line. This is a shorter line. So this is plus and minus. For voltage source, the polarities will be given. But for the resistor R1 and R2, the polarities, they won't give the polarities. You have to assign the polarities. How to assign the polarities here? So according to the Ohm's law, what we discussed here, whenever the voltage is connected at this particular circuit and R1 and R2 are connected, whenever it is a closed path, current is flowing. Current is flowing. That is denoted by I. I is flowing through the circuit. When I is flowing through the circuit, current is flowing through the R1 resistor. So I is flowing through the R1. According to Ohm's law, what is the I into R? Mathematical expression. Multiplication of current into resistance will give what? Please respond. Multiplication of voltage into current. Ohm's law lo cheppanu kadamma.
Voltage, sir.
Very good. Voltage. So whenever the current is flowing through the R1 resistor I into R, when this I is flowing through this R1 number. When the I is flowing through the R1, there is some voltage drop. For this resistor, you can say the voltage drop. Voltage is drop across the R1. That can be found by using the Ohm's law. So I into R, as it is a resistor, is R1. The voltage is given as a V1. What is the V1? Voltage drop. Voltage drop across this R1. Voltage drop across the R1. So that is V1 here. That is what? V1 here. But for voltage, you should mention the polarities. For voltage, you should mention the polarities. Here you have to mention the polarities. For the source, they will give the polarities. The drop across the resistor is voltage drop. For that voltage, you have to give the polarities. The polarity should be like this. As it is an observed element, I will tell what is the passive element and active element. As it is a passive element, the polarities should start from plus. The current is entering at this terminal. So we can write this is a plus. And at this terminal, the current is leaving, right? Current is leaving. So we can write minus. So for this polarities of the voltage polarities of the R1, we can write plus and minus. Okay. And again, the same current is flowing through the R2 resistor. So at this particular point, I is flowing. Then you can say I into R2. What is the I into R2 according to Ohm's law? Voltage. As it is a resistor 2, you can say V2. As it is a voltage, voltage is having a polarities, plus and minus polarities. Otherwise, it is a meaningless. Okay? Should give polarity. Yeah. So there is a power cut, small interruption. Now is the screen visible, Amma? Please respond.
Yes, sir, it's visible.
The power is, there's some power interruption is there. So that is the reason why sometimes network may be disconnected. Please be on the line. Within 2 minutes or 3 minutes, I will rejoin with mobile data. Okay. Yeah, see here. Here across resistor R2 also, there is some voltage drop. Across the resistor R2, there is some voltage drop is there. That voltage drop is V2. So V2 equal to I into R2. So for this voltage also you have to give polarities. As this current is entering at this particular point, you have to give this plus, and here you have to give the minus here. Okay, now? After having these polarities of for battery, they will give polarities plus and minus. For this R1 and R2, there is a voltage drop as V1 and V2 because the current is flowing through the resistors R1 and R2 because same current is flowing. According to Ohm's law, V1 equal to I into R1, that is V1, and I into R2 is V2. For this, you have to give polarities. There is some rule for this, for giving these polarities. The starting terminal where the current is entering should be treated as a positive, and at this particular point it is leaving. So it should be written as a negative. Like that, you have to give the polarities. Now, while writing the KVL algebraic sum, how many voltages are there in the circuit? Please tell me. Any voltages unnayamma ee circuit lo? Please respond, anyone. One is V0, source voltage. Another one is V1. Another one is V2. How many voltages are there?
3,
Total
sir.
3, very good. 3 voltages. Okay. And why have to find this V1 here? Because the KVL says that algebraic sum of voltages. See the statement. Sum of the voltages. That is the reason why we calculated the voltages across the R1 and R2. If all the voltage sources are there, then there is no issue, no need to calculate. But if there is a resistance, we have to calculate the voltage. Okay. Now algebraic sum of all voltages around a closed loop equal to 0. That is the statement here. Now, while writing the algebraic sum, we have to follow again some sign convention. Now, what is the sign convention? The sign of each voltage polarity of the terminal first encountered in traveling around the loop. For writing this writing the sign convention, you have to assign the currents. As the current is I, you have to take clockwise direction. We can take any clockwise or anti-clockwise direction. But universally, we will follow the current is flowing in clockwise direction. In this fashion, the current is flowing. And the arrow is very important. The sign convention is very important. While you are writing the KVL equation, if the current is entering at a particular polarity of the starting polarity, that can be that polarity can be treated as that voltage polarity. That means, see here. So this is the correct direction of the current. The current is entering at a negative sign or positive sign initially. As we are moving in this fashion, current is clockwise direction. The current is entering at negative sign or positive sign initially.
Negative, sir.
Yeah, very good. Negative sign. As it is in negative sign, while writing the V0, you have to give minus V0. You have to give minus, and again you have to travel in clockwise direction. While you are traveling clockwise direction, for this V1 voltage, where the current is entering initially, where the current is initially, where means at which polarity. For V1, we have given polarities plus and minus. At which polarity this current, I current is entering? Which polarity initially?
Positive.
Positive. As it is a positive, for V1, we have to give the sign as positive. And the same current is flowing in this fashion. Initially, where the current is entering for this polarity of V2, again it is at positive. So we have to write plus V2. So this is the meaning of algebraic sum of all voltages around a closed loop is equal to 0. Okay, na? If you take a clockwise notation, you will get this equation. Or clockwise notation, you will get this equation. We can also assign the current in counterclockwise direction. Counterclockwise direction, if you write, then you will get this equation. But we will follow this equation because universally you can follow a clockwise direction. So I will follow this notation, right? That is the meaning of algebraic sign. Okay. Again, I will take another example to understand this concept. I will write a circuit here. Please understand carefully. this is, let us take a Vs source voltage like that. Polarities are given, plus and minus, and there is a R1 resistor, there is a R2 resistor, and there is a R3 resistor. R1, please, am I audible, Amma?
Yes, sir.
Okay, okay, thank you. Now, if there is a battery and there is a closed path, is
Sir, explain, sir. Your
please.
voice is not clear, sir.
ఇప్పుడే పవర్ పోయి వచ్చిందమ్మా, ఒక్క నిమిషము మళ్ళీ కనెక్ట్ అవుతుంది. ఇప్పుడు ఓకేనా? ఇప్పుడు వినిపిస్తుందా? హలో, now it is clear?
Yes, sir.
Okay, thank you. Yeah, current is, once the closed path is available, current I is flowing, and through each and every element current is flowing. For this given circuit, you have to write a, which one? KVL, Kirchhoff voltage law. But here only one voltage is there, that is Vs voltage, a source voltage. But current is flowing. So that if current I is flowing through the R1, there is a voltage drop, and if the same current is flowing through the R2, then I into R2, I into R1, next I into R2, I into R3. Here also the same current is flowing, I into R3. So I into R1 is V1, I into R2 is V2, I into R3 is V3. So there are three voltages are there, three voltage drops are there across each and every resistor. So that this is V1, voltage drop across R1, this is V2, voltage drop across R2, and this is V3, voltage drop across R3. For this, you have to give the sign convention. Resistor is a passive element which can absorb the what you call energy from the source, which will act as a load element. For load element, if the current is entering at this terminal, for that particular voltage drop, which sign you have to assign? Just now we have discussed plus and minus. Likewise, can you give polarities for VT here, V2 here? Please, as the current I is entering at this point, initially this is plus and this is minus. Okay, and across this R3 there is a voltage drop V3. So current is entering in this fashion. So this is plus and minus. Okay, na? So this is the way we have to assign the voltage polarities for the resistor. This is the first step. You have to find out the voltages across each and every resistor. Second point is you have to assign the polarities for the voltage across each and every resistor. After that, you have to assume the current is flowing in clockwise direction. Current is flowing in clockwise direction. Now, according to KVL, can anybody tell me, by using the sign convention, can anybody tell me the KVL equation for the given circuit? So totally how many voltages are there? How many voltages are there?
Four, sir.
Yeah, very good. Tell me the KVL equation, Amma, Vaishnavi. Please tell me the KVL equation. You have to see this current direction.
V1
Clockwise direction.
positive, sir.
V1
V1
positive
positive direction.
plus
V2
V1
positive
V2 positive.
plus V2 plus
Ah,
V3
very good.
minus V4
Minus
V4.
this is not V4
V naught.
V naught or Vs given is equal
Okay,
to
sir.
0.
0.
So this is the way you have to write the KVL equation. Sometimes only voltage sources will be there. I will also give another example here. Wait. Once we are able to write this KVL equation, KVL and KCL, you can solve any problem. Suppose there is a battery voltage like this, like V1, another battery here. Only voltages are given, not resistors. Here the sign convention is not given. If the sign convention is not given, based on the particle battery symbol, we can assign the sign polarities. This is V2 and this is V3 and this is V4. How to give the sign convention for this voltage sources? What is the longer line? Means long.
Positive, sir.
Very good. This is plus and minus. Yeah. For V2, this longer line is plus, the shorter line is minus. Here, this
Minus, sir.
minus plus. Here plus and minus. For this given circuit, only batteries are connected up, no resistor and inductor. How to assign the current here? The current is in, let us say, I. We are following the clockwise sign. Please respond. Is the screen visible?
Yes, sir.
Yeah. Yeah, please, can anybody tell me the KVL equation for the given circuit? Start from V1, as it is a clockwise direction. Current, initially the current is entering at which polarity?
Negative, sir.
Negative means
Minus.
minus V1. Tell me the KVL, Amma, please. Next,
Plus V2.
plus V2. Next,
Minus V3.
minus V3, very good.
Plus V4.
Plus V4 should be equal.
Equal to 0.
Yeah, this is the KVL. Kirchhoff voltage law. So this is the sign convention you should follow for solving any problem. Okay? So based on this, I will give a small problem. Small problem here. By using the KCL, KVL and Ohm's law, try to solve this problem. So far we have discussed about the theoretical concepts related to Ohm's law, KVL and KCL. So let us apply those laws to calculate a current in a particular circuit. Let us take this problem. Simple problem. This is a 10 volts. So R1 equal to, let us say, 2 ohms. Next, R2 equal to 4 ohms. This is the circuit he has given. Now, calculate the current I which is flowing in the circuit. What is the I value? And current which is flowing in the circuit is how much? What is the V1? V1 is voltage drop across resistor R1. Voltage drop across R1. Next, V2 is voltage drop across R2. So we have to calculate V1, V2 and I here. So how to proceed for this problem? For this problem, first we have to find this current in a particular circuit. So there is a voltage V is here. For this, by seeing this article battery symbol, we can write this plus and minus. Always the current is leaving from positive terminal. Always the current is leaving from positive polarity of the battery. Always the current is leaving. But positive nunchi leave avutundi current eppudu anedi ilane flow avutundi. Okay na? So I have to calculate this current I. Very simple problem here. What is the Ohm's law here? Ohm's law, I equal to V by R. Okay na? But what is the voltage here? What is the supply voltage? 10 volts. The supply voltage by R. But if only one resistor is there, simply we can divide with the R 2. But how many resistors are there here? 2 resistors. Now these 2 resistors are connected in. Please tell me, is these 2 resistors are connected in series or parallel? Series or parallel? Actually, We have to discuss those series and parallel. Later we will discuss about it, but from the basics, we can easily say that these two resistors are, we will discuss about the series connection later. Simply by seeing these R1 and R2, these resistors are connected in series or parallel. ఎట్లా కనెక్ట్ అయినాయి ఈ రెండు రెసిస్టర్స్? These two are connected in series. Series అంటే ఈక్వలెంట్ రెసిస్టెన్స్ ఏమవుతుంది? R ఈక్వలెంట్ ఏమవుతుంది? R1 ప్లస్ R2 అవుతుంది. So 2 plus 4. Then what is the total value here? 6 ohms అవుతుంది. ఓకేనా? I equal to according to Ohm's law. Just వినండి అంటే నీకు ఎగ్జాంపుల్ చెప్తున్నాను how these Ohm's law, KVL and KCL are useful. Later we will do so many problems on this KCL, KVL. For understanding what is the application of the Ohm's law, what is the application of the KVL, KCL, I am giving this example. Ohm's law. By using the Ohm's law, I equal to E by R, V equal to 10 volts, R equal to 6 volts. Okay, na? So this much of the current is flowing through the each and every resistor. Okay. So for our simple calculations, let us take this is 3 ohms, so that it will be 5. It is 5 అయిపోతుంది. Then how much current is flowing? 10 by 5 is 2 amperes. So current is 2 amperes. Okay. Once if you know current, the same current is flowing. Okay, current is 2 amperes. Can anybody tell me what is the V1 value? Hello. What is the V1? Voltage drop across R1. According to Ohm's law, what is the V here? Another formula.
I to R.
V1, tell me V1. V1 equal to, current is I. Shall I write R1 or R2? I into R1. What is the I value? 2 ampere. And what is the R1 value? Again it will be 2. So finally how much voltage am I? 4 volt drop appears across the R1. Next, V2. What is the V2 here? I into R2. Current I is 2 amperes. What is the R2 value? We have taken 3. So 2 into 3, 6 volts. Okay, na? So finally, voltage drop across R1 V1 is 4 volts. Next, V2 is 6 volts. Okay, na? Now you have to assign the polarities for V1 and V2. How to assign the polarities for this passive element? Initially it is plus, minus. Initially it is plus and minus. Here there is a 6 volts. Here there is a 4 volts. Now apply the KVL. Apply the KVL. Current is entering clockwise direction. Current is entering at 10 volts at minus polarity. So minus 10. Next, plus 4. Next here, plus 6. That should be equal to how much amount?
0.
మరి 0 అవుతుందా ఇక్కడ? Are you getting 0 or not? Please. ఇది minus 10 now. 4 6 again 10, which is equal to 0. Kada? Total value becomes a, that is the what? Proof of KVL. That is the proof of KVL. Otherwise, we can also solve, let me take 2 minutes of time. We can also solve this problem by using the KVL also. This is 10 volts plus and minus R1, R2. This is I. So unknown voltage is V. Polarities are plus and minus. Here the unknown voltage is how much? Plus and minus V2. But we know R1 value is 2 ohms. R2 value is 3 ohms. Okay. Now write the KVL here. If you write the KVL, by KVL, Kirchhoff voltage law, minus 10 plus V1 plus V2 is equal to 0. Okay, na? So minus 10, what is the V1 amma? V1 is what? I into what? R1 plus what is the V2? I into R2 is equal to 0. Substitute R1 and R2 value in this equation. Minus 10. What is the R1 value? 2 into I plus. What is the R2 value? 3. 3 into I is equal to 0. So from this equation, 2I plus 3I is equal to 5I. If I write 10 RH side, then 5I equal to how much? 10. So if you write this, to further simplify, I equal to what? 10 by 5, which is equal to how many volts? Oh, sir, how many amperes? So in this way also, we can calculate the current. Simply it is what? I equal to V by R. So directly, initially we have written directly, but here we are following this KVL notation. Same value kadamma. Initially we got the same value here. Same value. I equal to V by R 10 by 5, which is equal to 2 amperes. Yeah, this is the application of the KVL. Once if you know I value, so then we can easily calculate V1. What is the V1 here? V1 equal to I into R1. V2 equal to I into R2. So V1 equal to I into R1, which is equal to I is 2 amperes. R1 is how much? 2. That is 4 volts. And what is the V2 here? I into R2. I is same na? 2 into R3 is 6 volts. So we calculated current flowing through the total circuit is 2 amperes. Voltage drop across the resistor 1 is 4 volts. Voltage drop across the resistor is 6 volts. So the total circuit is all about finding the current and voltage, power, 3 electrical quantities by using the KVL, KCL, Ohm's law. These 3 laws are very basic laws which are useful to calculate. If you know these fundamentals very well, we can solve any circuit. If some typical problem will be there, then we will be using theorems, or we will go for series and parallel connection, and we will go for, it is somewhat complex circuit, we will go for star delta convention, like that. So basic laws are Ohm's law, KCL, KVL. You thorough with these conventions and statements and application of this sign convention for KVL and KCL, it is very simple. Okay. So in next class we will do some more problems on KCL and KVL and Ohm's law. So before that, all of you go through this material. I will share the. I already shared this PPT in group, civil A group. Did you see that, Amma? I have already shared the PPT. Please respond. Shravan, 103.
No, sir, I did not see.
I have sent చేశాను Sai Kumar. Again, I will send. Please go through it. Once if you thorough with this sign again this material also, two PPTs I will send. If you thorough with this KCL, KVL and Ohm's law, in the next class we will solve some problems, so that you will get some clarity about these applications. Okay, na? I stop here. If anybody have any doubts, you can ask while writing the sign conventions.